solar system isn't a tidy place. Chunks of debris that never coalesced into planets float around in the asteroid belt between Mars and Jupiter, like so much unfinished business spoiling for a fight. Collisions beget collisions as impacts dislodge chunks of planets that themselves eventually crash into planets. These pieces are tangible evidence of impacts within our own solar system, impacts that happened billions of years ago, millions of miles away. And this chain reaction occasionally ends with these visitors from a distant place landing on Earth, bringing us information about the solar system.
They'll fly through the atmosphere at a tremendous speed and generate heat, pressure, start to burn, and many times these fragments will explode in the atmosphere and then rain down on the planet in showers.
Every child who has looked at the sky and seen a shooting star has seen an impact of extraterrestrial origin. Many of us have seen cosmic collisions. We just didn't realize that's what they were.
Meteors burning up in our atmosphere are common, but infrequently, some part of the meteor will survive to impact the Earth. By virtue of its survival, it has earned the right to a new name, meteorite, and it now has a bounty on its head. A rare breed of people, meteorite hunters, make it their business to track down these precious rocks that have traveled through our solar system in a pursuit that is part science, part commerce, and part hobby turned obsession. Jeff Notkin and Steve Arnold are two of the world's most prolific and determined meteorite hunters.
Sometimes we travel to godforsaken corners of the world that nobody would want to go to in their right mind, all in the hope of finding little pieces of cosmic debris. Why do we do it? Meteorites are amazing. They're a chance to hold a bit of an alien world in your hand.
They're also treasure, these pieces of other planets that land on Earth. There's a hierarchy of meteorite value. Not surprisingly, the rarest rocks have the most value.
Pieces of the planet Mars were blasted off into space by other meteorite impacts on the surface of Mars. Of the many, many thousands of different meteorites that have been found on our planet, only about 30 are from Mars. So they're among the rarest extraterrestrial material that we've ever recovered.
Martian meteorites are 35 times more valuable than gold by weight.
This little piece here, it's about 15 grams, and it's a piece of Mars. A conservative valuation on this piece would be about $15,000. So everything else on this table put together would not even equal the value of this one specimen.
As is true with many other meteorites, they can tell us information about the makeup of one of our neighboring planets.
Logistics and cost have prevented us from going to Mars and bringing back a sample. But the universe has delivered these rare examples to us free of charge through ancient impacts. Meteorites can also go beyond informing us about other planets. They have often served as a springboard for technological advances in the space program.
Meteorites were studied in the early days of spacecraft design. This is a very efficient shape for traveling through the atmosphere. As this meteorite flew through the atmosphere towards Earth, it kept this face oriented towards our planet, hence the origin of the term orientation. So as it flew towards the Earth in that fixed position, the surface melted and it curved back to form this beautiful shield shape.
Behind the shield, the meteor melts and warps, approaching temperatures greater than 1,000 degrees Celsius.
And this demonstrates very clearly the thumbprinting that's so unique to meteorites. These little indentations that are created as the surface melts. So meteorites that show orientation are not only rare, but they're very appealing to collectors who are interested in the sculptural aspects of meteorites and what happens to them when they fly through the atmosphere. You could never find a terrestrial rock, a rock from Earth, that looked like this. It's specifically its fiery journey through the atmosphere and the melting that has created this, which you might describe as an outer space sculpture.
But despite all their physical appeal, these space sculptures don't hold the value of their Martian cousins. or even their lunar counterparts. Pieces of the moon are second in rarity and value. Lunar impact craters are launching points for debris.
Some of those craters are enormous. Those ancient impacts will have thrown a huge amount of lunar material into space, and every now and then a little piece of it makes it here.
But most meteorites are refugees from the asteroid belt.
We can't physically get out to the asteroid belt yet as people. So meteorites allow us the chance to study the makeup of other worlds in our solar system.
There are sites that continue to be rich in meteorite finds. Brenham, Kansas has become famous for all sorts of digging.
This site here is the Brenham strewn field. Somewhere between 2,000 and 10,000 years ago, a giant meteor exploded coming in from the west-northwest, broke into a bunch of pieces and scattered pieces out in this farm ground out here.
Meteorites have definitely been found in this very field that we're in. It's exciting to be in a field. You know that they were here. Are there any left? That's what we're here to figure out.
To date, 4 tons of meteorites, pieces of our solar system, have been pulled from these fields, including Steve Arnold's find of a 1,430-pound, world record-sized Pallasite meteorite. These meteorites are composed of stone and iron and contain crystals of the mineral olivine. Pallasites are rare, valuable, and it takes work to find them. Like farmers working a field, Jeff and Steve must cover every foot of ground. Miss a spot, and they may miss the meteorite.